Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video is going to consider finite state machines. It's the second video in this particular series on finite state machines, and what we're going to do is we're going to construct a finite state machine, let's say to recognize okay, the language, and let's say the language is L2, L subscript 2, which is equal to the language that contains words A and the word B, and that these are over the alphabet. Okay, the language is defined over the alphabet that contains A's and B's. Okay, right. So let's start this off. Okay, so we're going to have a start state. Okay, let's call this S0. What this machine is going to have to do is it's going to have to recognize the word A. It's also going to have to recognize the word B, but it cannot recognize any other language. Now, we go back to our first video in the series, we defined different languages that consisted of words of certain sizes. Okay, in our previous video, and we defined L star to be the union of all of these finite languages, which gives us a language of all possible words composed of symbols A's and B's, okay, over this particular alphabet. So this machine that we're going to construct, it should recognize an A, it should recognize a B, but should not recognize anything else. Okay, and don't forget, the key thing here is it is possible that we could pass in any other word, okay, in L star to the machine, but it should not recognize it, and it should always try to, I suppose, let's say, eat each particular character in the word until it gets to the terminating symbol of the word that's been, or the string that's been passed to it. Okay, so let's construct the language let's construct the machine that recognizes an A. Okay, so what we're going to do is we're going to pass an A into the machine. Okay, and what we should do is we should consume an A. Okay, so we should consume an A, and we should then recognize the A. Okay, so let's say in state 0, when I consume an A, I'm going to go to a final state. Let's call that S1. Okay, so this machine so far, okay, it will definitely recognize an A, okay, because it consumes an A and takes us to a final state. Okay, but it is possible also that we could pass into this machine the character B. Okay, so if we pass in the character B, we're in state 0. Well, where we should go after consuming it is we should go into a final state after consuming it, and we should recognize it because it is in the language. So let's just actually consume from S0 once again into S1 on a B, and what we have now is that this machine here, okay, when I pass in the word A to it, it consumes the A, it's followed by the terminating symbol, then it knows it's in a final state, so it recognizes an A. If we passed in a B to it, it would consume the B, okay, and would also be in a terminating state, okay, so it will recognize a B. But what would happen if we passed in AA, or if we passed in AB, or if we passed in BA, or if we passed in BB to this particular machine, and so on and so forth? What about if we passed in AAA to the machine, AAB to the machine, ABA to the machine, ABB, and so on and so forth? It shouldn't recognize any of these, but it should always try to consume the characters that have been passed into it. Okay, so at this stage we recognize words of length 1 that are A's or B's, okay, but we shouldn't recognize anything else. So if I pass in an AA to it, okay, well, this machine so far will consume an A, taking me to S1. It hasn't reached the terminating symbol, so it won't ask whether it's in a final state, but we should consume another A, and that word isn't in the language, so we should take it to a state, okay, on an A that's not a final state, and let's call that S2. Okay, so now this machine here will consume an A, followed by an A, okay, and will then ask, am I in a final state when I reach the terminating symbol? Which it's not, so it doesn't recognize the A or the A. What about an AB? Well, it should read an A. There we go. It should read a B. It should not take us to a terminating state either. Okay. But it reaches the end of this end of input, and what it knows is it's not in a terminal state, so it doesn't recognize this machine. What about a BA? Well, it'll read a B followed by an A, read a B followed by an A, and it's not in a terminating state. What about a BB? It'll read the first B, taking us from S0 to S1. It'll read the second B, taking us from S1 to S2. Okay. And then it'll know that it's not in a terminating state, so it will not recognize that particular word. And we can continue on in this fashion. Okay. What about if it's strings that are passed to this particular machine that have more than 2 characters? Well, what we should do is we should just keep consuming and remain in this state S2. Okay, so what we'll do is we just put a self loop on this particular state here and consume A's and B's, and what this will allow to happen is it'll allow us to consume and read all strings composed of A's and B's, but will only ever recognize 2 particular strings, which is the word of length 1, that's an A, and the word of length 1, which is a B, and the other words have a greater length and it will not recognize them. Okay, let's consider another example. Okay. Let's say we want to we want to construct a finite state machine to recognize the language. Let's say the language we want to recognize, let's call it L3. Consists of an A followed by an AA followed by an, let's say, an AB, okay, over the alphabet, okay, and the alphabet that's over is the alphabet AB. Okay, so once again, like in our previous examples, we could pass in an infinite number of words into this particular machine that we want to construct. We could pass in an A, we could pass in a B, we could pass in an AA, we could pass in an AB, we could pass in a BA, a BB, we could pass in an AAA, an AAB, we could pass in an ABA, we could pass in an ABB, and so on and so forth. The only words that we want to recognize are the words A, the words AA, and the words, I suppose, where's AB, and the words AB. So the words that we'd like to recognize are the words A, AA, and AB. Okay, so let's start off with the smallest word. Okay, the smallest word being the word that has the single character A in it. And let's build a machine that will at least recognize that particular word. Okay, so we're going to start off in S0, state 0, and what we're going to do is, okay, we're going to pass in the word A to the machine, and what it should do is it should consume the A. Okay, so it should consume the A. Okay, and it's after consumption of the A, there's nothing following that particular character, okay, in the input. Okay, so it should be in a final state. So let's call this a final state S1. Okay. So this machine at this stage will consume a single A and bring us to a final state. What about if we pass in a B into this machine? Well, we shouldn't accept it. We should consume it, but we shouldn't accept it because it's not in the language. So what we should do is we should take the B, we should consume it, okay, and we should take it to a state, let's call that S2. That's not a final state. So you can actually see now this machine, when I pass in an A, it consumes it, and it tells us we're in a final state on the end of the input. That's good. When we pass in a B, it'll consume it, okay, but on the end of input we see that's not in the final state. Okay. What about AA? Well, when we pass it in an A, it consumes it. Okay. Now when it reads another A, okay, so when we read the first A, it consumes it. When it reads another A, okay, it should consume it, and it should be in a final state. Okay. So what we really need to do is we need to take this machine into a final state on when we consume 2 A's in a row. So let's call this final state here S3. Okay. So actually at this stage now, this machine as is, yeah, recognizes an A because when we consume an A, we're in a final state.